Okay, everybody, hi. I'm going to go over the test 3 review for Math 107 and walk through the step-by-step on how to solve each of the questions. I kind of already did and wrote it all out, went through that. So I'll just walk through it. You can always stop and rewind if I'm talking too fast and watch it again. Okay, so here's the test 3 review. We're going to start with number 1, which is from section 7. Chapter 7, section 1 on confidence intervals. Sorry, it's been a long day. And we're going to talk about the fact that we want to find an estimate of a confidence interval, 90% confidence interval for the population mean. So the information given is you have a sample size of 40. From that, we got a sample mean of $100 and a population standard deviation of $17.50. So since it's the population standard deviation, we use a Z distribution to solve this. So for a 90% confidence interval, you're going to use our chapter 7 formulas information. For a Z confidence interval, you're going to use 1.65 as the critical value of Z. So you're going to calculate the margin of error here, which is the critical value of Z times sigma, the standard deviation of the population, divided by the square root of the sample size. So we're going to take 1.65 for the critical value of Z times the population standard deviation, $17.50 divided by the square root of the sample size 40, which gives you, when you round to 2 decimal places, approximately $4.57. So going to the confidence interval formula for a Z distribution, you're going to take the sample mean minus the error, margin of error, less than mu, less than sample mean plus margin of error. So $100 minus that margin of error, $4.57, gives you $95.43, less than mu, less than $100 plus $4.57, $104.57. That's our 90% confidence interval. We have a 10% chance of being incorrect in our estimate for the mean costs for the population of repairing washing machines. To go to a 95% confidence interval, the only thing that changes here in this is that the critical value of Z is now 1.96 that we're using to calculate our margin of error times the the population standard deviation over the square root of the sample size, which gives us a margin of error of about $5.42, which we subtract from the sample mean and add to the sample mean to get our 95% confidence interval, which is $94.58 less, 58 cents less than mu, less than $105.42. That's our 95% confidence level estimate for the mean cost of repairing all washing machines. We have a 5% chance of being incorrect. When we go to the question C with a 99% confidence interval, what changes is our critical value of Z is now 2.58. So we then put that in the margin of error calculation, 2.58 critical value times the population standard deviation divided by the square root of the sample size, which gives us about $7.14, which we subtract from our sample mean of $100 and add it to the sample mean, which means then we have a 99% level of confidence that the true mean repair cost for all washing machines is between $92.86 and $107.14. That seems low to me. We have a 1% chance of being wrong. Maybe that's a part of the country where everything's cheaper. And then our question D says, which interval is wider? So what changed here was not the standard deviation. That stayed the same. If that had gotten bigger, it would make the confidence interval wider. What did not change again was the sample size. If that had gotten bigger, the confidence interval would have gotten smaller. But what did change here was the level of confidence. And as the level of confidence increases, then the confidence interval gets wider. So the 99% is the widest interval. To have more confidence in our estimate, we have to cover more numbers. So we've got a wider interval. If we go to question number 2 here. Question 2 says we have a random sample of 51 DVR players. The mean repair cost X bar $75. The sample sample standard deviation is $12.50 S. So since we only have a sample standard deviation, we have to use the T distribution for this confidence interval. And so Grab that. Okay. So first of all, we have a sample size of 51, sample mean X bar 75, sample standard deviation $12.50. So the first question is for a 90% confidence interval. So we have to calculate the degrees of freedom, which is the sample size minus 1. So 51 minus 1 gives you a degrees of freedom of 50. So we go to our T distribution with degrees of freedom 50. And it was a 90% confidence interval. So we go up here to confidence intervals, 90%, 50 degrees of freedom, we get a critical value of T of 1.676. 1.676. That's what we're going to use for our critical value of T. And now we do our calculation for margin of error the same way we did with the Z distribution. Here's our formula, almost the same way. Critical value of T times the sample standard deviation divided by the sample size, square root of the sample size N. And so we're going to take critical value of T times the sample standard deviation divided by the square root of the sample size, which is going to give us approximately $2.93, which we then subtract and add to our sample mean to get our endpoints here of our confidence interval, which gives us $72.07 less than mu, less than $77.93. So we think that the mean cost of repairing DVRs, I think it was, lies between $72.07 and $77.93 with a 90% level of confidence. So we have a 10% chance of being wrong in that estimate. Now, when we go to question 2B, it asks for a 95% level of confidence. And so now, again, our degrees of freedom was N minus 1, N was 51 sample size. So we're going to go again to our T distribution, 50 degrees of freedom. Now we're going to go to the 95% confidence level, 50 degrees of freedom, gives you a critical value of T of 2.009 that we're going to use in calculating our margin of error. That's what's going to change. So critical value of T times the sample standard deviation divided by the square root of the sample size, which gives you about $3.52 for the margin of error, which you subtract and add to the sample mean of 75 to get this 95% confidence interval for the population mean cost of repairing DVRs, I think it was. Then when we go to a 99% confidence interval, we're going to take, again, 50 degrees of freedom. The sample size was 50. Degrees of freedom is N minus 1. Now 99% confidence interval. So we go here to 50 degrees of freedom, 99% confidence here, which gives you a critical value of 2.678 to use for our critical value of T. So we put that in the margin of error calculation, critical value of T minus samples times sample standard deviation divided by the square root of the sample size, which gives you about $4.69, which then again we subtract and add to our sample mean of 75 from into our sample mean of $75 to get our 99% confidence interval for the mean repair costs for the population of DVRs. Okay, so falls in, probably better just to buy a new one at that point. So then we go to question 3. Still from chapter 7, says a cheese processing company wants to estimate the cholesterol content of all 1 ounce servings of cheese. The estimate must be within 0.5 milligrams. So that's our margin of error, how close we want to be of the population mean. The population standard deviation sigma is 2.8. Determine the minimum required sample size to construct a 95% confidence interval for the population mean. So we've got our information here. And what we're going to do, 95% confidence, again, we're going to go to the critical value of Z is 1.96. We know the population standard deviation, so we use the Z critical value, 1.96. We have to go to this formula for minimum sample size, critical value of Z times population standard deviation divided by margin of error, then square that and then round up to the nearest whole number. So we put these numbers in, critical value times population standard deviation divided by how close you want to be, the margin of error. We do that calculation, we get 10.976, which we put in our calculator, 10.976. We square it, not square root, but square it which gives you 120.47 something. We always round up because it means 120 is not enough. We need something more, and you need a whole sample, a whole serving. So it's 121 servings. So you always round up in this case. When we go to number 4, it's a similar question from chapter 7. An admissions director wants to estimate the mean age of all college students enrolled at a college. The estimate must be within 1 year. So that's our margin of error of the population mean. How large of a sample must she select if she wants to be 99% confident of getting an interval that contains the true mean? Standard deviation of the population is 1.2 years. So again, because we know the population, we can use the Z, critical value of Z for 99%, which is 2.58. We know the population standard deviation, and we want to be within 1 year. That's our margin of error. So we put Z sub C times sigma over E. That gives you 3.096. When we put that in our calculator, when we square it, you get 9.582 something. Again, you always round up. We want to know how many people, students to sample. You can't have 9.5 students, so you always round up. So the minimum sample size is 10. So I'm going to stop here. I'll shoot another video over the chapter 8 stuff so the videos aren't too long.